Then let's look at the fraud strategy management. We talk about some main tools. Then how do you use those tools to drive the approval, decline, or referral decisions? Usually it's data driven, right? So here, let's first look at a very important concept called the false positive rate. So the idea is that you want to design a rule, right, to catch the fraudster, but it's very hard to design a rule that capture 100% of all the fraudster. So in reality, that the rule, even it's a good rule, right, it will catch some fraudster, but at the same time, you will capture some good customers who happen to demonstrate the same behavior, right? So that's called a false positive. Okay, that's a good customer, a good application caught by the same fraud rule. Okay, the false positive rate is calculated as the number of applications that are actually good divided by total number of applications captured by this particular fraud rule. That's called false positive rate. For example, we have a rule to identify the high risk area in the metro city. If all applications coming from this area, so we want to identify them and decline them, right? So through data analysis, you know that for every 100 applications from this high risk area, there are 20 are bad, right? 20 are fraudulent, but the 80 applications actually are good. So your false positive rate for this particular rule is 80 divided by 100. That's 80% false positive rate. Okay. But still, the good thing is that you capture 20%, so that's good. But the bad thing is that you are pissing off 80% of a good customer. Okay, it's always a balance. It's always balance. A similar metric is a good bad ratio, right? It's the same idea, just different ways to measure this. Good bad ratio is the number of good applications versus the number of bad applications. Okay, follow the same example. For the 100 applications, we have 80 good applications, 20 bad ones, or fraudulent ones. So the good bad ratio is 80 versus 20. That's a 4-to-1. Okay, it's the same thing as 80% false positive rate. Okay, so how do we use the false positive rate or good bad ratio to drive the actual approval decline decision? Let's look at an example. So the decision should be based on a profitability analysis. Okay, so when the fraud rate is too high, okay, your false positive rate means is low enough. In that scenario, you would not earn any money from this particular population as a whole, because there are just too many bad accounts there, right? So once they get approved, they will hit you at the maximum. They will take out all the credit limit, while your good customer, they only utilize maybe 20%. So earn some revenue. That's the reason you cannot have too many bad accounts there, right? So in this simple example, we have 3 tiers, right? The first row is a false positive rate is less than 90%. So, or it's equivalent to good bad ratio is less than 9-to-1. For every 9 good accounts, there's at least 1 bad account or even more. So through the calculation, this is, again, you need to factor in your particular portfolio. So what's the average purchase? What's the average loss? You can calculate that usually the profitability for this segment is negative. That means you are losing money as a whole. Okay, in that case, you can just decline the population. Even though there for every one bad account, maybe there's still 8 good accounts, but you just cannot afford to approve them. Okay. Then the next tier is that false positive rate between 90% to 96%. That's a good bad ratio is between 9 to 1 or 20 to 1. Okay, so it could be every 25 good accounts, you have at least one bad account. Okay, so through calculation, you know the profitability is marginal. You earn money, but you earn some, not a whole lot, right? So in this case, for customer experience purpose, you can still approve them. You can approve them, right? But at the same time, you have your fraud detection people, right, to go over each case to see which one should be flagged, and then you can still have opportunity to stop the fund, right, being transferred. So usually there's some time gap between the approval and the fund goes out, or the credit card goes out. So that's one way to do it. Or you can just refer all these applications in a queue, right? So then you have people go over them one by one. So obviously that's more time consuming. So you have to see whether you have enough manpower to really do that, right? So because some customers, they expect decision, within a day or two. You don't want to wait for 7-10 days to give answer, because nowadays consumers, they expect faster and faster decisions. Okay, so you could, for these marginal applications, some are good, some are bad, but still marginal profitable, you can refer all of them, or you can approve them, but still you should assign someone to review them. Maybe you can still capture 2 or 3 bad guys from there, then you still save quite a bit of money. Okay. The last scenario in this example is false positive rate greater than 96%. That's equivalent to good bad ratio more than 25 to 1. So there are still some bad accounts, but usually they're all good, right? So profitability is very positive. In this case, you just approve all of them. Okay, knowing that there might be one bad egg out of 50 good accounts or 100 good accounts, but that's part of the business, right? That's cost of doing business. So that's the example for how we look at the false positive rate or good bad ratio to drive the approval, decline, or referral decision.